Hello again, Internet peoples. Please note this is a re-release of a video from my old channel, A Digital Mind. In this video we're going to be covering how to use one of the very useful physics methods in Unity, the Raycast. This Swiss Army knife of a method is useful for everything from shooters through stealth games to platformers. It really is a method that all game developers should master. If you find this video useful and want to hear when further helpful tutorials are released, don't forget to click subscribe to get notified. So let's get started. Starting with a new 3D project in Unity. First of all, let's get our scene set up. So let's have a look at our main camera. I'm going to set the background to black and turn off our skybox. And then we're going to set ourselves down a plane as a surface to work from. And let's set that plane to be quite large. Let's scale it up by 10, 10, 10. Well, actually, it should just be 10 on the X and Z. Okay, and let's give that plane a nice material to differentiate it from the other objects. We'll just set that to a light grey and drop that onto the plane. So next up, we're going to create our pointer that we're going to use in our environment, and that's just going to be a capsule. And we will scale that on the X to 0.5 and Z to 0.5, and let's rotate that, I believe on the Z, 90 degrees. And we're going to raise that up just off the surface, 0.5. Okay, and we actually want to rotate that not on the Z, but on the X. So it's looking away from us. And then we're just going to adjust our camera slightly, so let's take our camera up. And we're going to rotate that to look down at the floor a bit more. And we're going to move it forward slightly, so. And up a bit more and rotate again, just so we can see our pointer properly. Okay, so that's the basics of our scene setup. So the next step is to give our capsule a script. So let's just call that a new script. I'm going to call that capsule script. And let's open that up in Visual Studio and start coding. So transitioning across into Visual Studio. The first thing we will do is we're just going to actually use the debug draw ray command to demonstrate the ray that our capsule will be projecting. So for that, we need a vector free as a starting point. So that will actually be the position of our capsule. And then we need it to point in a certain direction. So we're actually going to use the transform to direction. And we're going to use the new vector 3. But we're actually going to use up because it's local to the capsule itself, so up will be out of the end of the capsule. And we're going to do that by set distance for now, so 10. And we're going to colour that in red so we can see it nicely in our scene window. Made a typo there. So let's build that and transition back into Unity and run. And we should see now that we're drawing a ray out of the end of our capsule in red. So keeping in mind that that is simply in a debug method so that we can see our rays that are being drawn. In our actual game, that will be doing nothing. So we need to transition back into our code and actually use a raycast to project a ray out of the end of our capsule to hit objects in our scene. So transitioning back to the code. The first thing we're actually going to need is something to store the output of our raycast. And that will be a RaycastHit. RaycastHit. And we're simply going to call that hit. And what that will do is store all the details of the objects that our raycast hits. And the next thing we need to do is use the physics class to actually generate the ray and see if we hit anything. So it's quite simple to do this. It will return true if it hits anything. So if we use an if statement and call out Physics.Raycast, and we want it to emit from position of our capsule in the direction as before, as we did with the debug draw ray. We transform to direction, and we want to do a vector3 dot up. Okay, so it's going out away from the end of the capsule, and whatever it hits, we want it to output into the hit RaycastHit variable, and we want that actual ray to go on forever. So we use infinity. Okay, and we'll just encapsulate that below. And if we hit something, for now, we're just going to log something into the console window. So that we can see it hit an object. We're going to move our debug up just before the if statement. So let's build that and check for errors. And transition back into Unity. Hit run. And of course, at the moment, there won't be any output because we're not hitting any objects. So let's correct that. So let's stop the program from running. And we're going to create ourselves a 3D object, cube. At the moment it's sitting over our capsule, so we just needed to move it up a little bit. So it's on the surface and away from our object. So let's stick it 10 out from our center point. Now if we hit run, we should see something being logged in our console. I've hit something because this ray, which we can't see here because it's invisible, is actually hitting that cube. So this doesn't demonstrate that the raycast is actually hitting the cube very well. So let's change that and make it a little bit more obvious. So going back into our project window, and let's create ourselves a couple of materials. We're going to have a hits material, and we're going to make that red, and probably allow that to emit colours as well in red. And we're going to then create our standard material, the normal colour for the cube, with no hit, and make that grey. Next, we need to add ourselves a new script to the cube object itself. Let's add component, new script, call that cube script, and we're going to open that in Visual Studio. And the first thing we need to do is create ourselves a couple of public variables for materials. So public material hit, material not hit. And we probably also need a bool for that, a private bool called is hit. false to begin with, because the object won't have been hit when it opens up and starts. So let's build that. Transition back into Unity, select our cube, and assign those materials. Transitioning back into Visual Studio, into the cube script, we need to add ourselves a public method that allows us to set the isHit ball. So being hit, and we'll set isHit equals true. So that's its sole purpose, is to set that to true. And then we need to use that to actually set our material. So going into the update, we can use an if isHit, and we can use get component renderer to grab the material object and set that to the hit material. Else, if isHit is false, we can get the component renderer, set the material to equals not hit. So the problem being at the moment is we set the isHit to true, but we never set it back to false if our ray moves off it, or if it actually isn't set. So if we change the isHit here to false, at the end of every frame it will reset it to false. It will then do a raycast check, call the being hit if it's being hit, which will set this to true. So let's build that script and check for errors. There's no errors, so let's transition back into Unity and hit run. And of course, it will change our material to the not hit material, but not the hit material, because we're not calling the method at the moment to tell our cube that it has been hit. So let's create that. Transitioning back into Visual Studio and into the capsule script. Within our if statement now, we need to make a call to the game object that has been hit. So to do that, we use our RaycastHit variable. We look at its collider and the game object of that collider, and we need to get the component, which will be our cube script, and make a call to being hit. So what that will do is when our ray hits something or hits this cube, it will store that information in the hit variable. We can then call the collider of the game object that was hit, select the game object, obtain the script, and then call the method within that script. So if we build that, check for errors, no errors, transition back into Unity, hit run, and now our cube turns red because it's being hit. To demonstrate this a little further, just to make it clearer, I think we need to add a couple more steps to this code. So let's transition back into Visual Studio, into our capsule script, and we're actually going to make our capsule rotate. So let's get a float rotation to store our input of the horizontal axis, which is our arrow keys to the left and the right. And then we're going to use that information to rotate our object, our capsule, to a new vector 3, 0, 0, I believe it will be minus rotation because it's looking away from us on the z-axis. And if we quickly build that and check it for errors, no errors, transition back into Unity and hit run. Using our arrow keys now, we should be able to rotate our capsule left and right. And as you can see, as we go over the cube object, it shows the is hit, and as we go past it, it goes to the is not hit material. So let's just emphasize that a bit more. So let's make our cube a prefab, and we're going to drop in another copy of that cube, and let's move that across to the left, and then a second copy of that cube and move that across to the right. So now have 3 cubes that we can hit. And if we now alter the angle of our camera so we can see our ray properly, not our camera, sorry, our scene view. So let's just change this around so we can see our ray properly. And if we now hit run and use our rotation, we can see our ray goes off, hits these cubes, and changes their colour. That's a good demonstration of how we can use a combination of Raycast, RaycastHit, and our debug draw array to actually use rays within our games, which is one very useful feature of the Unity game engine. I do hope that you find this tutorial useful. Raycasts are a very powerful feature of Unity, so you really do need to get to know them. If you like this video, please don't forget to hit the like button below and subscribe. If you have any questions, please ask away in the comments and I'll try to answer where I can. Apologies for the inconsistent sound during this video, as it is a re-release of an old video I produced using old equipment. Thank you for watching.